All right, 11.5. So we went over what a rational expression was and how to simplify it. And then in this lesson, we're going to go over how to multiply and divide with rational expressions. And then the next section will be how to add and subtract with them, okay? But multiplying and dividing, if you recall how you multiply and divide a fraction, right? So if we were going to multiply 1 over 2, so 1/2, times 3 over 7, right? You would just multiply the numerators and multiply the denominators, and then simplify if you could. So we would get 3 over 14, okay? It's going to be the same with rational expressions. And division, right? So if we were dividing fractions, it was 1 over 2 divided by 3 over 7. Remember that you keep the first one, change the operation, so change it to multiplication, and then take the reciprocal of the second, and then just multiply across. So we get 7 over 6, okay? So those are the rules for multiplying and dividing. So if you are multiplying fractions, a over b times c over d, and they can be rational expressions now, so they can have variables, then we multiply their numerators and multiply their denominators, okay? If you're dividing two fractions, so a over b divided by c over d, then you keep the first, change the operation to multiplication, and take the reciprocal of the second. And then you can multiply like you did with multiplication, okay? So multiplying, just multiply straight across. Dividing, change it to multiplication, take the reciprocal of the second expression, keeping the first one as it is. All right, so doing this with some examples, right? So let's do 7 over 7n to the 5th over 5n to the 5th times 10n to the 3rd over 14n. Okay? And actually, let's change that to n squared here, 5n squared. Okay? So multiplying rational expressions, okay? We are just multiplying straight across. So in the numerator, I'm going to put the numbers together. So it's going to be 7 times n, because we can multiply in any order, times n to the 5th times n to the 3rd. Then in the denominator, we're going to do 5 times 14 times n squared times n. Okay, just like fractions, simplify if you can, right? And here, 7 and 14 can simplify. I can put a 2 here and a 1. Then 5 times 2 is 10, so that's a 1. So all the numbers simplify to just 1. Then all the n's, when you are multiplying like bases, we're going to add the exponents. So we get n to the 5 plus 3. And then the denominator, this is a n squared and an n, so we'd get n to the 2 plus 1. Okay, so simplifying, that's 1, so we don't need to write the 1. We get n to the 8th over n to the 3rd. Now it is like bases again, and you're dividing, so we subtract our exponents. So n to the 8 minus 3 would be n to the 5th. So that entire thing simplifies to n to the 5th power. Okay? All right, we have y minus 5 over 3y minus 3y squared times 2y squared over y squared minus 6y plus 5. What I would do on an expression like this is I would simplify everything if possible, or factor, okay? So y minus 5 we can't simplify. That's y minus 5 times 2 times y squared. We're just multiplying across, okay? Then here, 3y minus 3y squared, I'm going to factor out 3y, and then that would be 1 minus y, and then y squared minus 6y plus 5 can factor. Factors of 5, so it would be y minus 1, y minus 5. Okay? Then, before you multiply everything, see if things cancel that are common to numerator and denominator. So I get a y minus 5. I'm going to cancel the y minus 5. Then I'm going to cancel a y. Okay? And I end up with here, in the numerator, what's left is 2 times y. And then in the denominator, there's a 3. Then what's different between 1 minus y and y minus 1 is a negative. So if I factor out a negative here, then this turns to a negative 1 and a plus 1. So then I get y minus 1 times y minus 1 with a negative out in front. And that simplifies to negative 2y over 3y minus 1 squared. Okay, because these two terms were almost identical except they differed by a negative. So I factored out the negative and made them look the same. So I could just simplify it to one term squared. Okay, so multiplying rational expressions, multiply across. You might need to do some factoring to simplify if possible. Okay, but just multiply across. All right. Two x plus 1 over 2x squared minus x minus 3 times 2x minus 3. Okay, first thing is to remember, just like a whole number, if it's just an expression, you can put it over 1. Okay, then I'm going to factor. So I can't factor. 2x plus 1 is already factored times 2x minus 3. That's our numerator. Then we're going to factor 2x squared minus x minus 3. So factors of 2 and negative 3 that add up to negative 1 would be 2x minus 3 and x plus 1. Okay, then it's times 1, because that's this denominator. Then I see a 2x minus 3 in both numerator and denominator, so I can cancel them, and I get 2x plus 1 over x plus 1. Okay, these are not the same terms. You cannot cancel them out. Okay, they don't have common factors to them. All right, division. Okay, so I have n minus 2 over 2n divided by n minus 2 over n plus 5. Okay, so division is different, right? Keep the first rational expression, so we get n minus 2 over 2n. Then I'm going to change the division to multiplication, so times. I'm going to take the reciprocal of the second one, so n plus 5 over n minus 2. Okay, then with multiplication, you multiply across. So I get n minus 2 times n plus 5 over 2n times n minus 2. Then you notice there's an n minus 2 in the numerator and in the denominator, so we can cancel. And we get n plus 5 over 2n. Okay, we have one more. So we have 5x squared minus 20x divided by x plus 5, or over x plus 5, divided by x minus 4. Okay, so the first thing is x minus 4 is over 1. Then division tells us keep the first one. We're going to factor this as we go. So we can factor out a 5x from both terms. So we get 5x times x minus 4 over x plus 5. Then change it to multiplication. So times, then the reciprocal of this. So 1 over x minus 4. Okay? Then as we see, there's an x minus 4 in both the numerator and the denominator now that it's multiplication. So we can cancel them out. And we get 5x times 1 over x plus 5 times 1. So 5x over x plus 5. Okay, so multiplying and dividing rational expressions.